This is video number 1 for sections 8.1 and 8.2, finding the domain of a rational function. In chapter 8, we meet our fourth type of function this semester. We've done linear and exponential and quadratic, and now in chapter 8, we do rational functions. A rational function is created by forming the ratio of two polynomials. You can see a couple of examples here on the handout. This is an example of a rational function. It's a ratio. Ratio just means fraction. So it's a fraction. And how did I create it? Well, I put a polynomial on the top and a polynomial on the bottom. In this case, I've got a quadratic on the top and a linear on the bottom. In this second example, another rational function, I've got a cubic on the top and a quadratic on the bottom. Anytime you make a ratio like that of two polynomials, you've got a rational function. Now, it turns out that this type of function is a little bit more complicated than the other ones we've looked at. I mean, you can probably guess that just from taking a look at these things. And so, therefore, in Chapter 8, we're really just going to focus on the algebra side of these types of functions. We'll leave the graphs and the modeling and other stuff like that to a later course. Essentially, we have three skills to talk about in this lesson, and in this video, we'll cover the skill of finding the domain of a rational function. And I've got a couple of examples here that we can look at. Every unit we've done, we have talked about the domain of our functions, and so far it's been very boring because in all the other cases the domain was just all real numbers. Domain just means tell me all the x's you can stick in, and for linear functions and exponential functions and quadratic functions you can stick in anything you want. So the domain has just been all real numbers. Well, that changes here in this chapter because once you introduce the idea of a fraction, and I mean by that an algebraic fraction where there are x's everywhere, once you have this kind of fraction, you may have a problem. Hopefully you realize what that would be. The problem with a fraction is that you cannot have a zero in the denominator. Now, when I say that, I don't mean you can't fill in 0 for the x. I mean that whatever you do fill in for the x can't create a final answer of 0 in the denominator. That is because division by 0 is impossible in math. You cannot divide by 0. You can try it on your calculator. Type something in like 7 divided by 0, and it will tell you undefined or impossible. So basically, if I want to find the domain of this function, it's going to be close to all real numbers. I mean, I think I can stick just about anything I want into this. I just cannot stick in a number that will make the bottom part, the denominator, come out to be 0. Well, here's the kind of work that you show for these problems. I'm interested in finding what you might call bad x's, right? An x that would be a problem, that would cause me to have an error. Well, the only way you're going to get a bad x, you're going to do the same thing every time, is if the bottom part comes out to be 0. In fact, sometimes what I'll do is I'll put a slash through this to read not equal to 0. I want to make sure that this x minus 3 guy does not turn out to be 0. Well, if you solve this little equation for x, what you end up with is essentially the domain. We're saying that 3 would be a bad x. And so you can put any x in you want to this function except for 3. I'm sure you saw that already in your head. 3 take away 3 here would make 0. Okay, so how do I give the final answer? Well, you could say it in words. You would just be writing all numbers except 3. Or you can write it just like we did as we were doing our work. X is anything but 3. And this is probably the standard math way of writing the domain. Again, what are we saying? We're saying you can put just about any number you want into this thing, just not 3. Okay, let's take a look at the second example. The second example is a little bit more complicated, and this is why showing your work like this is so important. This one's a little harder to figure out in your head. Well, you don't ever have to figure these out in your head. You do the same thing every time. If you want to find the domain of a rational function, again, you are looking for bad x's. How do you find the bad x's? The only x's that would be bad would be if the bottom, if the denominator, comes out to be 0. Again, I can remind myself I'm looking for bad x's with the slash. You'll notice that in these kind of problems, the numerator is totally irrelevant. It really has nothing to do with finding the domain. The only issue is making sure the bottom isn't 0. Okay, if I can solve this equation, then again, I will know my bad x's. Well, this is a more complicated equation. This is a quadratic equation. This is what we learned about in the last unit. We came up with 4 different methods for solving quadratic equations. The easiest of them all is the factoring method, so I'm going to really hope that that one works here. How do I do that? I get a 0 on one side. I already have that. Then I factor the left side. I don't see a GCF. I see 3 terms, so that means this is somebody's FOIL problem. It looks like a pretty simple one. You could do the X box, but I think I can work this one out pretty simply. The front has to be X and X to make X squared. The back, 2 numbers that times to 14. I mean, what do you got? 1 times 14 and 2 times 7. I'm thinking the only way I'm going to be able to make a 5 would be with a 2 and a 7. Let's think about the signs. Let's see, I want a negative 5, so I'm thinking that means that I'll have to have a negative 7x and a plus 2x, and you can double check that. I think that all works out. Then I use the zero product principle, so either this guy is 0 or this guy is 0. Again, I'm using the slash to remind myself of the bad x's. You don't have to do that. Looks like I end up with x equaling negative 2 as well as x equaling 7. Well, what are we saying here? We're saying that this time there were 2 bad x's. Negative 2 was a bad x and 7 was a bad x. The domain is essentially just what we've written down here. We're saying any numbers except for negative 2 and positive 7. You could check this out if you wanted to. All you'd have to do is go back up to your function and plug those numbers in and convince yourself, oh yeah, if I do that, I get a 0 in the bottom. For example, take the negative 2. If you stick negative 2 in here and square it, you'd get 4. If you'd stick negative 2 in here, that's going to turn that to a positive 10. And if you work out the math here, this part comes out to be 0. That's a problem. That's why we're saying that negative 2 is a bad x. If I ask you to find the domain of a rational function on a quiz or a test, this is the kind of work that I want to see. Later in this chapter, we will see that this bad x thing becomes important, particularly when we try to solve equations involving rational functions.